lesson, we are going to do a review of your Test 2 study guide. Your test will cover sections 1.3 through 1.7. Your test will consist of approximately 20 to 35 questions. You will have a decent amount of questions on your study guide, 5 full pages. However, I give you so many problems that way that you have sufficient practice for your test. Make sure that you ask any questions either through email during my office hours or during class, and I'd be more than happy to help you out with those. Remember the homework for sections 1.3 through 1.7 that is due the day of the test. So it's always due at the beginning of class, so make sure that you get that taken care of. Remember, partial work's always better than no work, so if you do just get a little bit of it done, you can always turn that in as well. So we're going to start off with section 1.3. Remember, I'm going to work the study guide in the same order that it should be on your test, so you shouldn't have any surprises. So they ask you to list the terms of each expression. Remember, when I'm asking you to list something, you're going to separate it either with those slashes or with commas. Okay? If you were just to rewrite 4a to the third minus 3a squared, well, you're not necessarily listing the terms. All you're doing is rewriting the problem. So I know that you know what terms are if you separate them either with commas or with those slashes. I don't care which one you use. So when we list the terms for problem number 2, we use 5x squared as our first term, then negative 7x, then 3. I will tell you that the reason why most students miss these problems, they either do not separate the terms or they forget these negative signs. Guys, your terms are going to either be positive or negative, and if they're negative, you need to write that when listing them. You will not get any part of the problem correct if you do not list any negative terms. All right, circle like terms in each list. Like terms are when you have the same exact variables paired with the same exact exponents. Remember, the variables are the letters. Your exponents are the tiny numbers up at the top. Okay? So here we're looking for things that have the same exact of those. Whether they're positive or negative doesn't change anything, and whether the coefficient, which means the number in front of the variable, that doesn't change it either. So I see that we have m squareds. 5m squared, negative 4m squared, and then m squared as well. Don't let that one confuse you, and I didn't mean to include that 3, so that's not included. And I don't put this in there to confuse you, but I want to make sure that you understand that this is also a like term with all of the others, because it has an understood number to be a 1 in front, so remember, those coefficients aren't going to change anything. So on number 4, I noticed that we've got some AB squareds in there. So I've got a 4AB squared, a regular AB squared, and a negative 3AB squared. This 4A squared B doesn't count because the exponent is in the wrong place. Notice in the circled ones how the squared is behind the B. Over here the squared is behind the A. That's why we can't use that one. Okay? So combining like terms. When you have like terms, you have got to have the same exact exponent and variables, okay? So we're just combining their coefficients. And like I just said, a coefficient is the number in front of the variable. So I have 9x plus 7x is going to give me 16x. Now we're looking at number 6. I like to separate my like terms by doing something different with them. So for all of my x's, I'm going to use a little underline, and then for all of my y's, I'm going to use that little squiggly underline. So I have negative 3x minus 5x. Well, negative 3 minus 5 is negative 8, and then don't forget the x. Whenever you combine like terms, remember your answer is always going to be a like term. Then 2y minus 7y is negative 5y. Don't forget to put your answers on the answer space. Remember, if you do not do that on your homework or your exam, I will not grade those problems because they do not look complete. Now looking at number 7, I've got my 5x to the thirds, and those are my only like terms. So I've got a 5x to the third minus 2x to the third, which is going to give us 3x to the third. And since these are not like terms, I can't combine them, so I'm just going to rewrite them. Okay? Remove the parentheses in each expression. Simplify where possible. So remember, whenever you have a negative in front of a set of parentheses, that means that you're finding the opposite. You could also think of this as having a -1 right here, and you have to distribute that -1. I don't care whichever way works best for you. So if we're doing the opposites, you have to do the opposite of everything inside of here. So the opposite of 8x is -8x. The opposite of -2 is a +2. So your answer would be -8x plus 2. Or you could say, okay, I've got a -1. -1 times 8x is -8x. -1 times -2 is +2. So whichever way you do it, you still should get the same answer. So here, I'm doing the opposite of what's in this set of parentheses. So that 5x is not included, so I'm going to bring that 5x down. So the opposite of 3x is -3x. The opposite of 4 is -4. Then I have some like terms I can combine, because remember it says simplify where possible. 5x minus 3x is 2x, and we're going to bring down that -4. Okay. Now let's move on to page 2 of your study guide. And I didn't separate these out on your study guide, so this is going to cover all of the parts from 1.4 through 1.6. So on 10 and 11, they ask you, is the number in parentheses a solution to the given equation? Well, they're going to have a number in parentheses on both of the problems, and what they want you to do is plug it into all of the variables inside. And then they want you to say, okay, is the left side, and remember we know our sides by where the equal sign is, does my left side evaluate to give me the same thing on my right side? Okay, so I have 5 times 2 minus 3 equals 7. I got that by plugging my 2 in for my x. So 5 times 2 is 10. And then 10 minus 3 is 7. So 7 does equal 7. And notice all I did was kept bringing that 7 down because I wasn't doing anything with it. So since that worked, we're going to say yes. You should not put the number 7 in here for the answer, because I didn't ask you what the solution is. I said, is that number in parentheses a solution? So that is either a yes or a no question. So do not put a number there. That's a yes or no question. On number 11, and if you want to put those lines through your equal sign, that's perfectly fine if that helps you. So I'm going to plug in 4 this time. Okay, so to evaluate the left side, I would do 5 times 4 first. 20 minus 8 is 12. Okay, so then I do my 3 times 4 first, which is 12. 12 plus 2 is 14. Well, 12 and 14 are not the same numbers. So that means that this does not work. So we're going to say no, that is not a solution. Okay? Label each statement as an expression or an equation. Well, it's an expression if it has no equal sign. It's an equation, think equal equation, if it has that equal sign. 12 is an equation. 13 is an expression. And then 14 is an equation. Ooh, I messed that up. Remember, if it has an equal sign, it's going to be an equation. If it does not have an equal sign, it will be an expression. So now we're going to solve each equation and check your result. Remember, you can check your results by plugging them back into the original equation. So negative 9x equals 36. Well, remember, to solve an equation, your whole goal is to get this x by itself here. Well, what's in the way of x being by itself is that negative 9. And remember, we know how to solve because we do the opposite that's being done to x. So when we have negative 9 right next to an x, that means multiplication. So the opposite of multiplication is going to be to divide by that negative 9. Okay? So those negative 9s cancel out just to give you a 1, so that would be a 1x. And then 36 divided by negative 9 is going to be a negative 4. And remember, you can always check your work by plugging this back in. So if we wanted to check, then we would say negative 9 times negative 4. So negative 9 times negative 4 is 36. So since these both equal the same thing, we know we did it right. That was the whole point of us doing problem numbers 10 and 11. That shows us how we check our work. Okay, so keep that in mind. Okay, on number 16, we'll notice that we've got two x's in here. And remember, the whole goal is to get x by itself. But you need to know which x to get by itself. So we always want to move all of our x's to one side. And if you recall from our class, we do that by moving the smaller value of x. So this is a 7, this is a 3. Since this 3 is smaller than 7, we're going to move it. The way we move it is by using the opposite sign. So since it's a positive 3x, we're going to do a negative 3x. And remember, what you do to one side, you have to do to the other. So 7x minus 3x is 4x. Bring down your 8. That 8 does not magically move to the other side. It's still on this left side of that line. And then 3x minus 3x gives us 0. It's okay to have 0 on one of the sides of the equal sign. Now we're going to subtract 8 from both sides to give us 4x equals negative 8. Divide both sides by 4 to get x equals negative 2. And you can check your answer by plugging it back into your x values of your original equation. So now let's look at problem number 17. So I'm going to go ahead and draw my line, and this problem is almost the same as number 16. We need to get all of our x's on one side, so I'm going to subtract 2x from both sides. So 4x minus 2x is 2x. Bring down that negative 7. Remember, it's still on the left side of that equal sign because we haven't moved it. Equals 0, because 2x minus 2x is 0. Now we add 7 to both sides. And then we divide both sides by 2 to get x equals 7 over 2. Fractions are our friends. It's okay to have a fraction for an answer. Okay? So now, let's move on to page 3. And we're going to do all solving equations on this one page. So the first thing I'm going to do is I'm going to get all of my x's to one side. There are no terms we can combine on each side, so I'm going to go ahead and get everything on one side. So I'm going to subtract my 2x from both sides, which leaves me with 5x plus 4 equals 6. And remember, I moved the 2x because it's smaller than 7x. I brought down this 4 here, and I brought down my 6 here. So now I'm going to subtract 4 from both sides to get that x closer to being by itself. 6 minus 4 is 2. And I'm going to finish by dividing by 5, because the opposite of multiplying by 5 here is going to be to divide by 5. So those 5's cancel to give you a 1, and x equals 2 over 5. Okay? So number 19 is very similar to number 18. So if you want to pause this video and see if you can do this one based on the work we just did on number 18, I think that would be a good idea to see how you're understanding it. So I'm going to draw my line through number 19. And this time it's a little different. I'm going to move the 2x. I'm going to subtract 2x from both sides. And if you remember, I moved the 2x because it's smaller than that 4x there. When I do that, I'm left with 7 equals 2x minus 5. So I add 5 to both sides because I want to get that 2x closer to being by itself. 2x equals 12. 7 plus 5 is 12. And then you divide everything by 2 to get x equals 6. Okay. On number 20 and 21, they're starting to get a little fancy, same with number 22. So on these problems, remember, if you have a set of parentheses, you need to get that taken care of first. So remember, your first is to get rid of your parentheses. Then you combine all of your like terms on each side. Then you move the smaller x, if you have 2 x's on each side, and then you solve. These are the steps that we learned when we learned from section 1.6. So I'm going to distribute that 5 to get rid of the set of parentheses. So 5 times 3x is 15x. 5 times negative 1 is negative 5. I'm going to bring down my negative 6x and my 3x minus 2. So we've taken care of the parentheses. Now we have to combine those like terms on each side. So I've got a 15x minus 6x is 9x. And I have to bring down that minus 5 equals, there are no terms that are alike on this side, so I'm going to bring it down. Now I move the smaller of my x's, which would be the 3x. So I get 6x minus 5 equals negative 2. And now I solve. So I add my 5 to both sides to get 6x equals 3. And then I divide by 6. Now, I want you to take yourself back to our very first lesson, which was section 0.1. I do not want you to say that the answer to this problem is 2, because it's not. Remember, when you're simplifying, you have to divide by a common number. So 3 divided by 3 is 1, 6 divided by 3 is 2. So our answer here is 1/2. Okay? The answer would have been 2 if it would have been 6 over 3. Okay, so be very careful that you're not rushing through that. So in number 21, I'm going to distribute that 2. So I'm going to bring that 5x down to get 2 times 3x is 6x. 2 times negative 4 is negative 8. And I'm going to bring down my 14x minus 7. Now I combine my like terms. 5x plus 6x is 11x. Bring down your minus 8. And there's no like terms to combine over here, so we're just going to bring that down. Now we move the smaller of our x's, which would be this 11x. 11 is smaller than 14. So I'm left with -8 equals 14x minus 11x is 3x. And I bring down my -7. We're going to add 7 to both sides to get -1 equals 3x. Divide both sides by 3 to get x equals -1/3. Okay. Now let's look at problem number 22. We've got two sets of parentheses here. So that means we're going to have to distribute twice. And one thing I want to point out to you is notice that that 2 is negative there. So be careful when you go and do that one. So 3 times 2x is 6x. 3 times -5 is -15. Then I've got -2 times x is -2x. -2 times -3 is a +6. Bring down your 11. Now, I'm going to combine my like terms. 6x minus 2x is 4x. And then -15 plus 6 is -9. Now, there are no multiple x's. I only have one x that's here, so I'm going to skip this step of moving the smaller x. So now I solve. Add 9 to both sides. Then divide both sides by 4 to get x equals 5. So now, y'all do not like this section for some reason, but it's not that difficult. We're going to solve these equations, but we're going to do that by getting rid of those fractions first, because nobody likes fractions, so let's get rid of them. So if we're going to get rid of these fractions, we have to multiply by a common number. So on 23, the first thing I'm going to do is I'm going to put this 5 over 1, just so I can see what all the denominators are. And I say that the common denominator, if I were to get one, would be a 12. So I'm going to multiply, and I'm going to use a different color for this. I'm going to multiply everything that has a denominator by 12. So every term is going to be multiplied by 12. So before I do anything, I'm going to want to cancel out my denominators. So here, I want you to imagine that this is all that you can see, okay? So 3 is my denominator. 3 goes into 12 4 times. So 4 times 2x is 8x. Now let's look here. 4 is my denominator. 4 goes into 12 3 times. So that's a negative. 3 times x is negative 3x. And then 1 and 12, that's still going to be a 12, so I multiply 12 times 5 to get 60. Okay. Now we're going to solve, okay? 8x minus 3x is 5x. Divide both sides by 5 to get x equals 12. Your answer will not always be what your common denominator is, so do not think that at all. Now let's look at 24. 24 and 26 are both very tricky, okay? So make sure that y'all are very careful while doing this problem. I'm going to multiply by my common number that all of these will go into, which is 6. Remember, only everything that has a denominator is going to be multiplied by 6. So 2 is my denominator. 2 goes into 6 3 times. So 3 times x is 3x. 3 is my denominator. 3 goes into 6 2 times. Now, notice there's two different terms up here. Whenever that happens, I want you to do this. Rewrite that minus and 2, and then we're going to put parentheses around the x plus 1. Do not go ahead and multiply here. You're going to get confused, so don't move ahead. And then equals, those 6's cancel, leaving you with just a 1. So now that you've got everything written out, now go ahead and distribute. So 3x minus 2x minus 2 equals 1. I got that because negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. So now 3x minus 2x is x. And then we're going to move that 2 to get x equals 3. Okay? Now, I've got 25. I'm going to put that 7 over 1 just like we did on number 23. And the common number that I'm going to multiply by is 20. Remember, I got that number because I want to find what both of these numbers will divide into. So 4 is my denominator. So 4 goes into 20 5 times. So 5 times 3x is 15x. Then 5 goes into 20 4 times. So negative 4 times 2x is negative 8x. And then 1 and 20 is going to be 20. So 20 times 7 is 140. 15x minus 8x is 7x. Divide by 7. X equals 20. All right, remember I said that number 26 is also a very confusing one, so be very careful here. I'm going to multiply by 15 here. Everything that has a denominator is going to be multiplied by 15. So 5 and 15 gives you 3. Remember I said whenever you have two terms over that one denominator, you're just going to put that x plus 1 in parentheses and then put the 3 on the outside just like we did here. 3 goes into 15 5 times, so we bring down our minus, bring down our 5, and then we're going to do x minus 6 equals 3 goes into 15 5 times, 5 times 1 is 5. So now we can go ahead and distribute to get rid of all of these parentheses. 3 times x is 3x, 3 times 1 is 3, negative 5 times x is negative 5x, negative 5 times negative 6 is positive 30. Now we combine our like terms. 3x minus 5x is negative 2x. 3 plus 30 is 33. Subtract 33 from both sides to get negative 2x equals negative 28. Divide both sides by negative 2 to get an x equals positive 14. Alright, so this next page, this last page, is going to be section 1.7 over linear inequalities. So on 27 and 28, they want you to write each inequality in words. So to give a little review, this is less than, and we talked about how that less than symbol looks kind of like an L, a capital L. This one is greater than, and then if it has a little line under it, you would just add or equal to at the end. So 27 says that we have x is less than or equal to -4, and you don't have to write out -4 in words, you can just put the number. The important thing we're looking for is that you can write that sign correctly. And then on number 28 we have x is greater than 12. So now graph the solution set of each inequality. Remember, if x is not by itself, you have got to get it by itself before you can graph, okay? And just so y'all know, each of these on your test should have these arrows at the end because we're graphing these on a number line. So that means that the line is continuous, it's never ending. So on number 29, we've got to get the x by itself. Remember, we discussed that we could imagine as if this was an equal sign. We're not going to change it, but just imagine if it was an equal sign. And we're going to get that x by itself by adding 2. So x is less than or equal to 11. So remember, we can put the 11 on any one of those 3 tick marks. I'm going to put it in the middle just to make y'all comfortable for now. And it's less than or equal to. Remember, if it's got that equal to, we have to put a closed circle. Okay? So that looks pretty close to me. And then it's less than. Well, if you're looking at any numbers that are smaller, lesser than 11, those are all going to be to the left. There is no question as to where I shaded and as to whether my circle is open or closed. Now, we are not finished because you cannot leave these tick marks blank. You've got to put numbers there so I know that you actually understand what numbers are smaller and larger. So the number that comes right before 11 is 10 and after 11 is 12. So 10, 11, 12. They do have to be correct and in that right order for you to get credit. Number 30, and I'm putting a dotted line there just so we remember these are inequalities. We have to move our x's over to the same side, so I'm going to move the smaller x. So that leaves me with x is greater than or equal to -3. So this time, I'm going to put the -3 over here. -2 would go here, and -1 would go here. I would use a closed circle, and you do not have to make your circles as big as mine. I'm just apparently in the mood to make a big circle. And then it's x is greater than. So if x is greater than, meaning larger than -3, then it's going to shade to the right. Remember, I also taught you that if it is a less than, you can just make it into an arrow and that shows you which way to go. And if it's a greater than, same thing. Notice how you went this way and how you went this way. So that is also okay. 31 is where I'm going to get you, so be very careful. In order to solve this one, you would have to divide by a -3. But remember, there's a rule. Whenever you multiply or divide by a negative number, you always have to flip that inequality sign. So instead of having a less than, we're going to make it a greater than. 15 divided by -3 is -5. This time, just because I can, I'm going to put my -5 over here, then -6, then -7. I'm going to use an open circle this time, and it's going to shade to the right because it says x is greater than -5. Okay. 32. All right, so I want to keep all of my x's on the left side while I'm working with inequalities. So I'm going to subtract to the 8x. So we get -6x is less than or equal to -3. Divide both sides by -6 to get x is greater than or equal to. Remember, they flip because I divided by a negative. and that would be a positive 1/2. We talked about that. Negative divided by a negative is a positive, and then when you divide both of these by 3, that gives you 1/2. Be careful there. So I'm just going to put them in increments of 1/2, so 0, 1/2, and 1. It's going to be a closed circle, and it's going to shade to the right because x is greater than 1/2, meaning x is going to be larger than. Okay? All right, now on number 33, I'm going to move my 4x to get x minus 2 is greater than 5. Then we add 2 to both sides. So x is greater than 7. I'm going to use 6 here and an 8 here, so 6, 7, 8. There's going to be an open circle on 7, and x is greater than, so that means it's going to shade to the right. I want you to notice how it is obvious which way I'm shading. There is no question about which way I decided to shade. And there's no question as to whether my circles are closed or open. Remember, the rule over here for flipping those inequality signs is if you multiply or divide by a negative number, you are going to have to flip that inequality sign. All right, I wish you the best of luck on your test. All right, good luck.